What we are going to discuss today would be about container packaging, who should ship, and how to do it. Uh, I am Akhil Mohan. I work as a software engineer at VMware by Broadcom. And also, I'm a container maintainer and a maintainer of Kubernetes publishing bot. And most of my work is like focused on the Kubernetes SIG node side. Okay, now the topics of discussion that we are going to have today is mostly about like packaging of applications, like mostly like the core applications that come in the system, then the distribution of it, and how containerd does it, and then like who should be actually doing it, because like it can be at the vendor or the distribution level or distro OS level, or the project itself can do it. So now let's go into packaging. So why do we really need packaging? So in many cases, the applications or binaries that you are going to use doesn't work like independently. It needs like some dependent, some configurations might be required, some other files might be required. So like since this is like mostly concentrate on container side, so if you can consider like example of like Docker, like for Docker you need like containerd to run, and then again for containerd you need runc to actually create the container, spawn the container, and then manage it. So which means like it creates a total dependency of like Docker, containerd, then containerd, and then runc. So and most of the people who use containerd like will be using it for like managing containers. There are some other use cases like if you just want to use it for like managing images and all. But like most of them will be like for managing containers. So in that case, like runc comes as a definite dependency. Now, another thing why we need the packages is like you need to get the supported versions together. For example, like runc has like runc you are on like one version and containerd on another version which has like a newer feature. And then when you try to create a container, it basically creates an issue because like uh, whatever containerd says like runc cannot do. There can be issues like that. And basically things like that have happened in the past. So this was like related to containerd earlier used to package like runc also along with it, and the containerd packaged one was basically depending on one version of runc, and this version of runc dependent on a particular version of seccomp, and most of our testing happens mostly on like Ubuntu, and this issue happened in like RGL 7 because the libseccomp package was different from what containerd expected, and some of the symbols were missing. So this sort of issues can happen with when the packaging goes wrong or like we are not doing it in a proper manner. And these issues are like kind of a regular occurrence, or you can say like most of the time it happens, and say always the discussion happens like who should be doing the packaging and like uh, how should it be like delivered to the end users. Now, when you look into the distribution side, so now we have created the packages. This has to reach the end users or like whoever it's intended for somehow. So that's like basically taken care by the distribution part. So most of you may have used like Red Hat or like Debian repositories are like one common method to distribute the packages. So like you just yum install or like apt-get install and then you get those packages. And another way is like you can also like just download directly from GitHub or like the release binaries, and it might work. And yeah, then like for if you consider the case of like Kubernetes maintain their own infra using OBS for like build and distribution. Like so Priyanka has mentioned about like OBS in the morning, like how they do the build and like how it was switched recently. And another container runtime project called CRIO uses this KTS infra for their like packaging and distribution. Container is actually not using it. We are following a separate approach. Okay, so now going to the container packaging. So since I mentioned like this much about container packaging, you may think it's like some complex process that we are doing, but actually we do the most simple thing, just deliver the binaries as is as a release tarball. Nothing fancy there, because like it reduces the burden on the maintainers, and for the users it provides a generic stuff they can install and get quickly started with. So just the release starballs, you will get the main container binary, some client binaries like CTR, and then the basic shim binaries. And most of these binaries, like all of them, are like built on Ubuntu machines. And yeah, this point I already mentioned. Yeah, and we officially do not maintain any depths or RPMs from the containerd side, and this is also like uh, a decision that was taken because like the maintenance effort is like a little bit big on maintaining the packages from the project side. Now, yeah, the packages are actually released via GitHub release artifacts, and like you can download them and extract and basically start with it on the go. Okay, now coming to our main point, like to the distro or like who or the vendor or the project, like who should be actually doing the packaging and the distribution. So distributions like Ubuntu or Red Hat can do it, or like the vendors like cloud vendors like Google, AWS also like does it on their own. So now first we will see on what like the distributions or like the vendors how they do it. So in the packaging side, mostly when you use it like instead of the project release artifacts, that's earlier mentioned like the binaries from the release starballs, people will be mostly consuming from the packages that are like shipped by the vendor. So that's what I mentioned, like you can just install from the Debian repositories and get those into working. And also even for containerd, if you see like Ubuntu maintains one package called containerd, and then there is another package that Docker actually maintains called containerd.io. So the difference between this is like Docker wanted some specific versions and some more custom configurations into their containerd package. So that's why like a separate version is maintained. And I think like most of you might have used Docker or like containerd will have installed from the the Docker packages. It's like available from the docker.com download URL, not directly from the Ubuntu repositories. So now if you go to cloud and infra vendors like Google, AWS, Azure, VMware, IBM, all of them ship their own version. So it's like because they need to know so they knows best like which are all the dependencies and libraries that are on their machines or like that they are shipping to customers. So this is again like mostly focused from an enterprise side, and they will have a stricter requirements like mostly from like maybe regulatory or like country specific requirements might be there that they need to follow. And for that like they follow a stricter pattern of shipping. And one example is like using the toolchain. For example, like containerd is like built using Go, and you may have seen like the upstream containerd may be built with one version of Go, and like the when you use like in Google or AWS, sometimes a patch version of Go lang may be used. And again, this is for like some regulatory requirements. Yeah, and another thing to notice is like for vendors, like they usually ship the dynamically linked packages. So this is like a case like specifically to runc. If you download the official runc release binary from upstream runc GitHub, it is like a statically linked binary that you get like with all the dependencies packed into itself, and like basically it can this is done because they want to be compatible with the most of the systems that are out there. And since runc is like a low level component, they don't want to have like runtime dependencies cause breakages. But for vendors, like this may not be completely suitable because there might be some libraries or like some licensing requirements for this. Like they cannot have like a statically linked binaries like shipped to the final customers. And so they do it with like a dynamically linked ones extra. So it's like again going to the licensing requirements, since most of these are like some of the dependencies like libc are actually like a GPL license. There can be issues with that statically linking into code that you're shipping into an enterprise. uh, Now going into the distribution side of a distro or like vendor. So all the vendors who create the packages have like their own channel for distribution also. Like And this distribution channels have like their own infra, and maintaining this infra is like not a not an easy task. Now, earlier I mentioned about the Docker giving their own packages of like runc and containerd Docker. And for this, Docker actually uses their own infra to release the deb and RPM packages. This is like specifically for they want to cater to their requirements. And this was like an issue open like last week only. Like there were questions from the community why Docker distribute like containerd like independently of like the Ubuntu package. So it's like still a discussion is going on, like, okay, should the project take it up and do it, or like let Docker like do it, or like we should like give more focus on the Ubuntu one. It's like kind of like an open discussion that always happens like every now and then, like should we take it up, but it's never reaching a conclusion kind of stage. Okay, now let's go to the like some positives and negatives of like when a distribution or vendor does the packaging and shipping. So one advantage that you can see is like there will be like specific requirement on all dependencies that can be met like when a specific when a vendor does it, because they know best like which are all the dependencies or libraries that they have embedded in their OS or like distribution, so they can compile the containerd binaries with those specific dependencies, and that will be like best for their customers. Now again, as I mentioned, like for the regulatory standards, and in most cases like there will be custom patches also that vendors have to maintain so that it's like properly supported. The direct one from upstream may not work in like some cases. Now looking at the disadvantages side, the upstream project may not be able to maintain all the issues, and like the so this is basically like initially I mentioned about the RHEL7 issue that came up with like libsecom. So yeah, all the issues like the upstream project may not be able to maintain, like so the downstream has to basically cater to it and then look into it and basically fix it. Also there can be like packaging issues that come up. So this was also another recent issue in the Ubuntu mailing list. So the Ubuntu package that they maintain, they released a containerd 1719 version, but accidentally their packaging setup picked up the 2.0 RC3 version, and it was publicly available for some time before they could roll it back. So it created actually breakages in many systems. So the reason why it was happened because there were some changes in containerd, but actually the releases happened in containerd for the RC3 and 1719 along the same time frame. So the Ubuntu system that picked up the releases got messed up, or like some issue happened there, and then the wrong version was picked up. So issues like this can also happen. Now when we go into project shipping, so that is basically the main project, upstream project itself, ship the packages, distribute the packages to the end customers. So you can never know the complete combination of all the distributions, packages, and the users, and like finally where this is going to be run. So in our case, like we can only follow a generic set of things and then do it. For example, like the current containerd binary that is available upstream, if you check, it's like built on Ubuntu 20, and we are still not able to upgrade it to Ubuntu 22 because of some compatibility issues. So when we update it to 22, some glibc issues come, and like there will be some user that we will actually break because of this issue. So there is like it has been stuck to Ubuntu 24 now almost for like 3.5 years, I guess. Even like 22 and 24 are available, but we are not able to switch to that. Now again the binaries will be like linked to again to Ubuntu libraries. So one reason I mentioned like Ubuntu is like used most of the places is because the infrastructure that we use for like building and testing is like mostly on GitHub Actions, and Ubuntu is like the most available OS there. So it's like most of the cases we are using Ubuntu. And when you link to Ubuntu libraries, the previous kind of issues related to dynamic linking can happen again. Yeah, this point I have like already mentioned, like it's always like so difficult to maintain every single combination of like the distribution package and then the dependencies and make sure it works. You need to have like sufficient test infra to make sure that all of this works, and it puts a lot of load on the maintainers to cater to all those needs. And another thing is like from the distribution side, like at scale, even the downloads can start to cost more. So like I think like whoever has worked in like the Kubernetes side would definitely know about it. So like you release a package or something, like there are a few users, you are okay, but like when you scale it to 1 million, then like your costs just shoot up. So that issue also we need to handle. Now, okay, so now again going to the containerd side, containerd earlier used to ship a packaged version like that was like CRI containerd bundle that contained the containerd binaries, and then the runc supported version of runc also. It was removed in like deprecated in 1.6 and completely removed in 2.0. Again, this is because of the fact that like we are not able to support it and we don't want to maintain it. Like officially, we don't want to maintain it, but still it is like available for whoever want to use it because of like tested from external infras like the Kubernetes CA actually uses this bundle to bootstrap their nodes in the cluster. And similar to this, containerd had a CRI CNI bundle, and this all along with the contents of the CRI bundle, it also included the CNI plugins all. So this means like that if you just extract this bundle into your local machine and like just give the path, and containerd will be like completely up and running, like along with the network working and everything. But this was also stopped because like the maintenance support going into this was to maintain it was too much. So now we always refer to customers like get the version of runc or which is compatible and then like do it. Now from the distribution side, sorry, yeah, maintaining the infra for like distribution, if you package it like distributing the Debian's depths and RPM is like again a difficult task. I think like the community project like Kubernetes might be like facing this now. And so for us, like the everything is like in the policy of like keep it simple. So distribution is like via GitHub, just do the GitHub release artifacts and okay, that's it and done. So now if you look into the positives and negatives of this, we have like a very minimal and easy to use starballs that like cater to most of the generic use cases. But if you want to switch to like a custom combination of some OS, then like mostly it will be better if you can switch your vendor given version. And since it's like mostly maintained by the maintainers itself, the current packages, like the issues won't be that much. At least we hope that. Now the disadvantage is what I mentioned. All the combinations will never be tested. So always there will be like some issue cropping up, like in a particular version, like some mismatch happened and now it's like started to break. Then we have to again bring up some system, like there it will be some old OS or some very old libraries that the user is having in his setup, which the maintainers have to then bring up and test it and find out, okay, why is this failing, and then provide a workaround for that. Issues like that can also happen. And this was like one issue that came in like around 3-4 months back related to the runc version. So runc had made one change in how they build the binaries. This basically resulted in the runc that was packaged in containerd to give a different version. So that was again a miss on our part on like why it happened. So yeah, so now I want to actually know like how, so there are other maintainers present here, how you are actually doing it, like because like we are also still figuring out like to exactly like who should be doing the packaging and who should be doing the distribution. So I want to know like how do you do the packaging, like how do you do the distribution, and like what are the challenges that you have faced when like doing all these things, like maybe like distributing to your customers or like it can be enterprise users or to the community. Or yeah, basically that's it. So it's like open.
I can just quickly talk about OpenSUSE Tumbleweed. We use OBS to package containerd. Like you mentioned, we do carry our own patches because for CNI plugin is one of the example we have. We want CNI plugins to be installed at a path that OpenSUSE understands. So just to answer your question, how do we package for the open source distribution, OpenSUSE Tumbleweed, we use OBS. And that is how we distribute as well. We produce RPM binaries, RPM packages there so people can consume RPM. For the distribution itself, that goes into the package repositories. So people can do zipper install, like for Ubuntu, they do apt install. Challenges, of course, there is always there are always challenges because we are carrying patches, and our OpenSUSE Tumbleweed is kind of our upstream for SUSE's enterprise Linux. So we are always catching up on those patches, and every time upstream, like you mentioned, because you can't upstream project can't test n number of distributions. So whenever things break, we have to redo all patches or rewrite all patches, and those challenges always stay, not just with containerd but also other container runtimes. Yeah.
Thank you. Anyone more want to share their stories or like how do they're doing it with their project? Or any questions like? Okay, yeah. Then like tomorrow there is a maintainer track in which like we will be focusing on like a new release of containerd and also more into like a contributor section, like how you can contribute and best areas for it. So it's happening at room 404. I think that is this, unless there is another building with the same room number. Yeah. Thank you. And if you want to connect me on like Slack, Twitter, anything. Yeah, good. There is a project pavilion booth also for containerd tomorrow from like 11:30 till 3:15. Yeah. There's a question.
Just very quickly, I want to understand where is the discussion going around containerd officially supporting the Debian packages for Ubuntu, and yeah.
Yeah, it's actually happening in the same thread like that I mentioned somewhere. I can find. Yes, yes. I'm just this one.
Okay, 0079. I just want to check, is it something that's actually containerd upstream project happily receiving, or what are the challenges that are being discussed right now? Because I was a bit confused earlier in the slides. You mentioned that containerd upstream project provides static binaries so that it can work.
Containerd does not provide static binaries. runc provides static binaries.
Okay,
but
runc
containerd is
provides.
like dynamically linked.
Okay.
Yeah.
So I believe that is also one of the reason why we build, because it does break. Yeah. Okay.